Hey, so going to be looking at a lesson 1.3, which is about ordering real numbers. And the goal for this lesson is to use rational approximations of irrational numbers to compare the size of those irrational numbers. So I know my writing wasn't the neatest thing there, but I'm kind of in a hurry. So what we want to do is we want to look at irrational numbers, which kind of hard to get a grip on, and change them into rational approximations so that we can compare them to other rational numbers and other irrational numbers. And we're going to use mathematical practice we're going to use for that is modeling. So when we model these situations, we're going to put them on a number line, figure out where they are. Because we can figure out where they are in relationship to each other, we can certainly figure out which one of the numbers is greatest, because it's important that we are able to tell if we have a group of 3 or 4 numbers, which one is greatest and which one is the least, okay, what order they're in. So let's get right to it. So first question on page 21 asks to compare the square root of 3 plus 5 and see if that 3 plus the square root of 5, and they want to know which one's greater. So really what we're talking about here is comparing. And if you remember, compare in the English classroom really means let's look at the things that are similar between two things so that we can address what's different. In math, however, comparing just means one thing. We want to know which one is greater. That's it. So what we're going to look here is we need to estimate the values that we've got here. So here we have a 5, we know that, and here a 3, and then we've got the square root of 3. I'll talk about that, and the square root of 5, we'll talk about that in a minute. Now we know that the square root of 5 is going to be greater than the square root of 3, or it should be. And we want to know if we add that to the 3, is it going to be more than if we add it to the 5, all right? So there's another video with this lesson that talks specifically about estimating square roots, all right? Estimating square roots. And if you're not comfortable with estimating square roots for right now, or if you haven't watched that video yet, I would watch that video, estimating square roots, because there's some pretty good stuff in there, if I do say so myself. And what we're looking at here is, before we do that, I'm going to estimate that with using a calculator. All right, I'm not going to estimate it. I'm going to use a calculator to figure out some of these square roots. Now this square root, this calculator that I've got is a business calculator, but it's going to round everything to the hundredths. And what it's going to do is it's going to estimate the square root of 3 as 1.73. And I keep saying estimate, but what it's really doing is it's rounding it to the hundredths because it's a business calculator, which is going to be enough for what I'm doing here. So this side over here, this is about 1.73, and that's 5. So 5 plus 1.73 is going to be 6.73, right? So the square root of 5 over here is what we need. And so I've got a square root of 5, which is 2.24. And we're adding 3 to 2.24. So we end up with 5.24. So this lesson goes very quickly. It's very simple. It's very easy. All we're doing is, hey, do we know about how big these, about great these numbers are? If so, write them down, add them up. What are we going to get, right? So you can see this 6.73 is greater than 5.24. So the answer is greater than. Okay. Same deal with if we look at example. If we look at example 2, which is on page 22, they want us to, instead of just look at 2 numbers and see, hey, which one of these is greater, what they want us to do is order these numbers. Square root of 22, pi plus 1, and 4 and 1/2. half. And they want them in order from least to greatest. It's almost always least to greatest. And if somebody said, hey, order these numbers, I would just do least to greatest. I wouldn't say, well, what order do you want them in? It's going to be least to greatest, right? Now, before I can actually compare these and put them in line or put them on a number line, what I need to do is look back at my goal here. I'm using rational approximations of irrational numbers. Well, this is not an irrational number. This is a rational number. So I'm just going to make that into 4.5, because if everything is in decimal form, it's going to be a lot easier to figure out which one of these things is greater and which one is less. Okay. Now pi is irrational. And when I add 1 to an irrational number, it just becomes an irrational number that is 1 more than it was before. So this is still an irrational number. But I'm going to use a decimal approximation, decimal approximation, and then use a rational approximation to decide whether it's more than 4.5 or less than 4.5. And since this is out to 1 decimal, I'm also going to take this out to 1 or 2 decimals, and then I'll maybe adjust from there. So this is 3.14 plus 1, which is going to be 4.14. Now, you know, I didn't take my pi out to 3.14159 and then keep going, because I'm just comparing hundredths to hundredths here. I don't have to keep going. If this isn't any more than this, it doesn't matter how many digits of pi you put behind this thing, it's still going to be less than 4.5 because of the positions that we're looking at right here. Okay? In fact, the first position, the 10th is the one that gives this one away. Then we want to look at square root of 22. Now, I know that the square root of 16 is 4, and the square root of 25 is 5. So the square root of 22 is going to be between here somewhere. All right? Now, if you haven't watched the video about approximating these, this is what I would do. I would put 22 into a calculator, hit the square root button. Now, again, this is a business calculator. It goes to hundredths. This is 4.69. And you can tell this one's the greatest, this one is next, and this one is least. So if I was going to put these on a number line, I would mark, why not? Let's just mark 3, 4, 5, and 6. I'm going to put this one is right in the middle. So it's right here. 4.5 is right here. This one is going to be closer down here, which would be 4.14. And then the 4.69 is pretty much 4.7, which is, if this was split up into 1, 2, 3, 4, 5 pieces, it would be at this one right here. So there's 4.7, all right? So we can tell that these in order would be 4.14, 4.50, and then 4.69, or it would have been pi plus 1 is the least of these, 4.5 is second, is greater than this one, and then square root of 22 is the greatest. And this is the answer we're looking for, all right? Now, if you're answering these things and leaving them in decimal form, I'm fine with that because that's what you were looking for anyway. But then when you get back, the square root of 22 is the greatest of the 3, all right? And that is the whole of this lesson. Now, some of them you're going to be able to look at and tell which one is greatest just by looking at it. Because if you're adding like a 5 and a 7, and you have something that you're adding to the 5 that is 1.4, like the square root of 2, and you're adding something to the 7 like the square root of 5, which we know is more than 2, then that one's obviously going to be greater, all right? So try to figure out before you calculate which one you think is greater, and then calculate it, all right? This should help you a lot, but all we're doing here is figuring out what the decimal equivalents or near equivalents or approximations are, and then we're putting them together, all right? And we're putting them in order that we need to, or we're finding which one is greater. Same. See ya. Do, 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 do.